My name is McKenna and I am presenting the Masonry Robot, or MR. It is a part of the robotic system that maintains an airport runway. Each robot has a distinctively different goal that it needs to achieve. The MR's responsibility is to fill cracks that have formed in the airport runway, and the instructions for where these cracks are provided by the surveyor drone in the form of coordinates. So taking a look at the machine, you will see two distance sensors, one on the front on the left side and one on the rear on the right side. And they are measuring at 10 feet increments because that is how far the machine will move at each time. There are two servo motors, one at the top of the screen in blue. That one controls the hatch to allow the cement to be distributed. And then you have the lower servo, which is connected to the arm of the roller, so that allows the roller to come down to smooth out the cement. On the very lower part of your screen, you'll see a wheel connected to a continuous server, and that powers the mixer inside of the hole that holds all of the cement to keep it fresh and ready to be used. So the MR utilizes 6 different gears to power its 2 bilateral treads. The 3 motors that are located on the lower part of the breadboard power the left tread, and then the 3 that are located on the upper power the right. The MR robot is also equipped with an emergency LED light that will flash anytime the distance sensors pick up an obstruction. So starting to walk through the code, at this point we've already put in the X and Y coordinates. It's checking for obstructions both in the front and in the rear. It won't come out of that loop until both are clear. And then the MR robot will start traversing along the X and Y axis to get to its target location. By default, the MR robot will always be sitting in a 0-degree position. The robot does turn on either a 90 or negative 90-degree position to move along the X-axis, but then it will return back to that 0-degree position when it's done with that 10-foot increment. Whether the MR is moving towards a target or back to its home base, it will always find its X coordinate first and then move on to find the Y coordinate. Here you can watch the gears turning as it's finding its X and Y coordinate. The gears on either side have to move oppositely when they move forward or backwards, and when they move side to side, they move together. The timing is shortened for the demonstration. The platform was having difficulties processing the code, so I had to strip down anything that was not necessary. So during this presentation, you have the full code located on the upper right-hand corner of the screen, and there is a running monitor at the lower right side of the screen. However, it is a few seconds behind, if you can see from the top of the simulator screen. In any case, the robot is coming up to its target location soon, and it will start to execute the program to fill the crack in the airport runway. The first part of that program that you will see is the servo motor located at the top in blue. It will turn at a negative 90 degree, and that is signifying that it is opening the hatch to allow the cement to come out and fill in the crack. The hatch door for the dispensing of cement is located on the front underside of the robot. The roller that will help make sure that the cement is evenly distributed, and its arm that raises and lowers it, is located on the front of the robot. And while the robot moves around, the arms are located up, so the roller is up off of the ground. And now that arm will lower the roller to the ground, so it can now distribute and flatten that cement that was just distributed out of the hole. And the machine will then go forward and back for 3 passes, and it will end up in the same location that it is in now. At which point the arm for the roller will then rise up and bring the roller up with it, and the machine will start preparing to return back to the home base. Just as the robot had found its way to the target location, it will also find its way to the home location using coordinates of the target and its current location and doing those calculations. Once it reaches the home base, it will go into standby mode and start to charge, and it will then await the next XY coordinates from the surveyor drone.